Capacitance. Uh, when you have boundary value problem, then how can you solve this boundary value problem? First, understand boundary value problem, in which potential is defined on boundary and calculation is done between the boundaries. The simplest way to set the boundary conditions for an electrostatic problem is to specify the value of potentials on all surfaces surrounding the region of interest. And the situation often occurs in practice. In the laboratory, we have conductors connected to batteries which maintain a potential, or a ground which is the experientialist words, that is potential equal to zero. However, there are other circumstances in which we do not know the potential at the boundary, but rather the charges on various conducting surfaces. Suppose I put a charge on QA in the first conductor and QB on the second, and so on. I am not telling you how the charge distributes itself over each conducting surface, because as soon as I put it on, it moves around in a way I do not control. And for good measures, let's say there is some specified charge density rho in that region between the conductors. Is the electric field how uniquely determined, or there perhaps a number of different ways the charge could arrange themselves on their respective conductors, each leading to a different field? So we have to require the uniqueness theorem, which is defined by Laplace equations. Let's do a problem, and you have a problem. Consider the parallel plate conductors shown in the given figure, where potential equal to 0 in the lower plates and potential equal to V equal to 100 volt at the upper plates, and the distance between center to the upper plate is Z equal to D as shown in the given figure. You have to calculate the potential and the electric field between those conductors. And also, this is charge free region, so this is charge free region, so rho equal to 0, charge density will be 0. Then from we go from Laplace equation. Laplace equation. Laplace equation said that del to V equal to minus rho by epsilon naught. Since rho equal to 0, therefore del to V equal to 0. This del to V is defined in this case in 3D. 3D Laplace equation. 3D Laplace equations. Now simply we integrate del to V by del Z square equal to 0. This is the first equation, and first integrate, then del V by del Z we got, which is constant of integration is C, and after integrating del V by del Z we got potential Cz plus D. It is a straight line equations where C and D, where C and D are constant of integration. As you know, at z equal to 0, this is z equal to 0 and this z equal to d. At z equal to 0, potential is 0, and at z equal to d, potential is 100 volt. So apply boundary value, apply these conditions. At z equal to 0, potential is 0. Therefore, if you put from this in this equation, equation 2 becomes 0 equal to 0 plus d, that is d equal to 0. This is third equation. And second condition, z at z equal to d, potential is 100 volt. So 100 equal to c into d plus 0, that is c equal to 100 by d. This is equation 4. Now using equation 3 and 4, in equation 2 we get potential equal to 100 Z by D. This is equation 5. This is the potential between plates. Now also know about electric field. This is the potential. This is the potential. How will you define electric field? Electric field is defined by electric field minus del V by del Z. Z cap. The directions of electric field is along Z cap. Therefore, minus 100 by D Z cap. This is the equation, so, and this is the uniform electric field. We got uniform. Now, are you understanding? Now you got two equations. Two. First, you find potential, which is given by equation 5, and electric field, which is given by equation 6. Now calculate. If you want to calculate capacitance, then capacitance is defined by charge per unit volume. Sorry, charge per unit potential. C equal to Q upon V. Now here capacitance is directly proportional to charge if, and capacitance is inversely proportional to its potential, or this is the potential. It is the already not the potential difference. It is a potential difference. So capacitance